Hi, today we're going to talk about the diesel engine and how it works. It's going to be a very short video because all I want to talk about is the working principle of the engine. You can see on the model here, this shows a typical engine. This is actually for a truck engine or a bus engine, but it is a diesel combustion engine and the working principle remains the same. So let's have a look inside the engine. Inside the engine, we have a setup similar to that displayed. I'm going to zoom in. What I'm going to do, I'm going to start the engine. You can see now there's a lot of movement and all of it looks, you could arguably say, slightly complicated. But the process is not actually that complicated. So we'll load up another model now and we'll have a look at exactly what's causing all of this movement. What's driving these pistons up and down? What's driving this wheel? And like I said, the process is actually simple. The model displayed now has some unique colouring and a very similar engine design. We can see already that inside the chamber is an area that's coloured blue. Blue actually signifies air. And what's happening now, if we'll zoom in and have a better look, we can see there's a gap here. These long sticks, these are actually valve stems and valve seats and valve lids. Essentially this is a valve. So these are opening and air is rushing in through the gap. And there's a reason it's rushing in. It's because the piston, which is this here, is moving down the cylinder liner. As it moves down, it draws more air in. Now notice the valves are now shut and the piston is at its lowest point. So the piston then begins to move back up the cylinder liner. Now this is where it gets slightly interesting. We're compressing the air. And you can see here now that these four long lines within the cylinder liner, these signify fuel injection. Now from the fuel injector head, or the nozzle, which is here, we're going to spray fuel, or we're going to spray diesel into the cylinder liner. And then things get very, very interesting. Because we're compressing the air, and there's fuel within the cylinder liner, it's then possible to get combustion. Now a fire triangle consists of oxygen, which we have in the air, fuel, which we just injected, and heat. The heat is actually coming because of the compression. When we're compressing the air, we're actually raising the temperature, and this increased temperature is going to cause the diesel to combust. So what we're actually going to get is a mini explosion within this space. The explosion would occur around about now or slightly before the piston gets to the top. And then once the explosion occurred, we're going to get a massive temperature increase and a massive pressure increase because the explosion wants to push the piston down the cylinder liner and the piston also wants to get away. So the piston moves down the cylinder liner until it reaches again the bottom. And then once it's reached the bottom, what they call bottom dead center, it's going to start to transit back up the cylinder liner. This is all caused because the piston itself can only travel in a linear motion, which is up and down. However, further down here, we can see that this is actually a rotating assembly. Everything along this line is actually rotating in a clockwise direction. So once it's reached the bottom, it travels back up linearly, and we get to our next interesting part. These valves here open, and the exhaust gas will be pressed out of the cylinder liner. We call it exhaust gas because we're not getting any more useful work from the fuel. Therefore, the fuel, which is mostly going to be carbonized now, is going to be pushed out of the cylinder liner, past these valves, and forms exhaust gas. Then the piston will reach the top again, the exhaust gas valves will close, and we can start to draw air back in again. And this process repeats and repeats. So all we're essentially doing is drawing air in, compressing the air, then injecting fuel, creating an explosion. The explosion pushes the piston back down, and then the piston's going to transit back up again, push the exhaust gases out, and the process starts again. Now, if you're struggling to remember exactly how this works, one of the best ways I was taught to remember this is suck, squeeze, bang, blow. Suck, as in now, suck the fresh air in, and then we're going to need to squeeze it. Bang, this is what they call a power stroke. Pushes the piston all the way down, and then blow. Push the exhaust gas out, or blow the exhaust gas out. Suck, squeeze, bang, blow. Very easy to remember. Some people then, after a while, once you've got used to remembering it, you can start to call it inlet, compression, ignition, exhaust. Anyway, that is essentially how a diesel engine or an internal combustion engine works. Nothing too complicated, very short video. In other videos, we're going to look at the construction of the engine and why we pick certain materials for certain jobs. In the meantime, if you get a chance, go to the website, click on mechanical machinery, and set up a page to help people learn the names of the engine components. This is it here, engine cylinder explained. Click on that model. It'll take a while to load up. Now, this is very useful because you actually want to learn the name of the components after you've learned the basic process. The reason is people start to refer to these components in conversation, and you'll need to know exactly where they are in your mind's eye. It makes it very difficult to understand the conversation or to follow what you're being taught if you have to always try to remember which component is where. You can see on the model again that we've got the inside of a combustion engine. If you click on each of the pieces, you'll get the name of the component and also a little bit about it. In addition to that, we actually put on some labels here, and these will help you understand exactly what's happening. Some very important concepts such as bottom dead center and top dead center are also highlighted. And once you've learned about all the components and the different phrases and terminology, you should be able to follow a conversation much better and understand much more about what you're being taught. Anyway, I hope you found that useful. Thanks very much for your time.